We're going to start our notes with the quadrilaterals unit, looking at some vocab, specifically about different types of polygons. The two that we have here are convex and concave. Now, a concave polygon, you can see in this image here, has a dent. So anytime you see a polygon go inward like this, and where you can draw a line to very clearly see that you have an inset angle, a dent like that, you are dealing with something that is concave. If not, if all the angles or all the sides push outwards, then you have convex. So this would be examples here of convex, convex. Concave has a dent. And you can see a dent like the one over here. So all angles and sides go out. Now we're going to skip down to different types of quadrilaterals and how we classify these. First one is just the standard quadrilateral. It could be any four-sided shape, doesn't need to have anything special about it. So let's say it looks something like that. No symmetry necessarily. As for markings on the outside or inside, I'm actually just going to put none here because there's no real special properties of a standard quadrilateral. And the only thing that we would write down in words here is that the sum of the angles, of the interior angles, is 360 degrees. That's something we already know, but just good to remember. It will be very useful for us. So sum of interior angles is 360 degrees. Now let's go on to our first more specific one, and this would be a trapezoid. The symmetry, we don't necessarily get any symmetry with a standard trapezoid. However, there are some properties that are going to be useful to us. So our markings on the outside are going to be the parallel arrows that we're used to when lines are parallel, because a trapezoid has one set of parallel lines. Now, the diagonals of a trapezoid don't necessarily do anything special. They'll cross, but we don't really know any special relationships about that, so we're going to just leave that blank for now. And then properties, if we were to put those to words, we're going to say that we have one set or one pair of parallel lines. I'll abbreviate parallel with the two parallel bars. So one pair of parallel lines or one pair of parallel sides, you could write. So that's just a standard trapezoid. Next one down, we have an isosceles trapezoid. That's also a trapezoid, but it inherits one extra property, which is that the sides here are going to be the same length. And just like an isosceles triangle, when you have sides of the same length, you also get base angles of the same length. And in fact, you'll actually get the top angles to be the same as well. And you still have parallel lines on top and bottom, just like we did with a standard trapezoid here. So going back to our first part, when we're talking about the symmetry, you can actually fold one of these things in half down the middle. So if we were to draw a little dashed line up and down like that, that would show where we would fold it for symmetry. We also get some cool properties on the inside. So the ability to nicely fold it in half is actually going to tell us that these diagonals here are in fact of equal length. They're of equal length. And along with a number of other things, that's going to allow us to, you could even prove, for example, side-side-side congruence in here, and from CPCTC, be able to get all kinds of angles that are going to be the same. And that it all ties back to that symmetry piece that we had earlier. But you could mark all kinds of angles as being equal to each other. So I'm not going to mark too many. The blue one is the important one, that they have equal diagonals. So if we're going to mark this, we have still one pair of parallel sides. We also have one pair of congruent sides. That's where the two sides are the same length. And I'm going to abbreviate congruent like that. I'll write sides here. So one pair of congruent sides. And we also have equal length diagonals. So congruent diagonals. Some of those angles that come with it, you could also write that. That is kind of implied based on the information we have, but you could write that as well. And then we're going to look at parallelograms. Now, parallelograms have a whole bunch of different properties. Interestingly enough, there is actually no symmetry, so we can't write that anything is symmetrical to anything, but there are a whole bunch of things that we do get for free with parallelograms. They're full of properties. First one, most important thing, is that we have two pairs of parallel sides. So we have these two sides across from each other, opposite, that are parallel. We have these two sides opposite each other that are parallel. So that's one thing that's true. I'm going to rotate through some colors because there's going to be a lot of things on here. You also get equal length sides. So these sides, top and bottom, are equal length. These sides, left and right, are equal length. You also get the angles across from each other of equal number of degrees. So this angle here across from each other, and then these angles across from each other are equal. So you get a lot of things with a parallelogram, a lot of free information. You also get a lot about their diagonals. So if you draw in those diagonals here, the diagonals are going to bisect each other, which means they're going to cut each other in half. So that's leaving you with equal pieces on either side of the diagonals. Along with that, because of the parallel lines, you get alternate interior angles all over the place. So we have these two across from each other that are alternate interior. We have this set of alternate interior here. We have also more alternate interior. We have, and I'm switching color, but these are different angles here. So those are going to be congruent to each other, and then these here are going to be congruent to each other. So we actually have four different pairings of angles. The ones with the single tick and the single tick with the hash through it are different. So things that we're going to write now, we're going to say two pairs of parallel sides, two pairs of parallel or of congruent sides, so two pairs of parallel sides, two pairs of congruent sides, opposite angles. Opposite angles are congruent. And we'll also say diagonals bisect each other. Bisect each other, EO. So we have opposite angles are congruent, diagonals bisect each other.